Welcome back. Monty here, and we are about to use the universal tool for this topic, the toilet paper roll, again. So the last couple of weeks we worried about circumference, then we worried about arc length, then we worried about sector area, leading us into the area of the bottom and the top is pi r squared. But now we finally get to three-dimensional figures. Okay? Volume. All right? So this week we're going to find the volume of three-dimensional shapes. And we're going to wrap the week up on Wednesday and Thursday by actually seeing how much this holds. All right, so let's get started. Week 34, we're on May 24th to the 28th, the last full week of May. And if you wanted, you could actually go into your textbook, page M475, and you'll see that in a second. All right, volume, surface area. You've got a cheat sheet, so you have these formulas, and we have our universal tool, toilet paper, paper towel roll. And last week we focused on sector area, the area of the bottom, the area of the top. This week we want to turn it into three-dimensional objects. Okay, so let's get started. First thing is we've got our cheat sheet for the formula for volume. Length times width times height. A sphere, 4/3 pi r cubed. A can, a cylinder, right? A cylinder. Our toilet paper roll. Pi r squared h? What does that mean? Pi r squared h. And if you notice, there is a typo, and I miss it every year, so you might want to grab your cheat sheet and fix it. The volume is pi r squared h. They forgot the r in there. Ugh. And I forget every year. Okay. And then we've got our right circular cone and these pyramids. We're not going to get to pyramids this year. All right. Let's get started. Now, what is a cylinder? What is a can? What is the volume of this object? So I love these that pull apart. Got this little disc, right? And we know that the area of this disc is pi r squared. Isn't a cylinder nothing more than tons and tons and tons and tons and tons of these circles stacked up? Just stack them up until you have a ton of them, and we have what's called a cylinder. Okay, so if you were to actually work out of the book, two-dimensional shapes are translated, rotated, or stacked. They can form a three-dimensional solid. So if we stack a whole bunch of cylinders, a whole bunch of these circles on top of each other, stack them, we build a three-dimensional figure. Okay, so in this particular case, imagine, I'll grab yellow here. Okay, stack, 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 right? Picture a bunch of coins, picture a bunch of poker chips, picture Pringles, potato chips, just stack them, stack them, stack them, stack them, stack them. And we end up with our formula, how many of them? H amount. Okay, so the volume of a cylinder, and I usually write it. Wow, nice handwriting, Monty. I think we should redo that. Oh boy, oh boy, oh boy. Are you guys getting used to my handwriting? Don't ever get used to this handwriting. From now on, the volume of a cylinder is the bottom, pi r squared, h times the height. okay, where h represents the height. All right? So now, go to your cheat sheet and fix it, okay, because what I printed for you is a mistake. Pi r squared h. And when we use pi, we can actually, for pi, we can use the button. When we use pi, we can estimate for 3.14, or just leave it in the final answer, leave pi, because that's what refers to the circle. And just so you know, I actually paid money for these posters. Okay? That were printed wrong. I should get my money back, shouldn't I? There's no R. Oh gosh. Gotta make a note. Note to Monty. It's written wrong. Okay, so now we have our volume of the cylinder. Let's get started. Let's do some practice. Again, don't forget, there's supposed to be an R in here. Okay, calculate the volume of each cylinder. In this case, we'll use 3.14 for pi, round decimals to the nearest tenth. Make a note, tenth is 1 decimal. All right, so Mr. Miller's handed out your note-taking sheets for the week. We just demonstrated that a cylinder is nothing more than a whole bunch of these little discs stacked up. So, step 1, volume pi r squared h, pi r. There's no R? Ah! Gotta make one up. Let's make one up. Alright, pause the video. Everybody in class, make up a number. Let's call it a 7. Okay? So we'll have 7. Actually, we don't want a 7 because we got a 7 here. Start this video over, Monty. 8. Let's call it an 8. So, 8 squared, 7 high. Okay? So, what's 8 times 8 times 7? Let's use our old-fashioned calculator. 7 times 7 times 8? No. 8 times 8 pi r squared times the height. 448. 8 times 8 times 7. 448. 448 pi meters squared. Okay, make sure everybody gets that. Now it said to multiply times 3.14, 1406.7, 1406.7 meters squared. Okay, is also a correct answer. All right, now you try one. Pause the video and everybody go. All right, welcome back. Hopefully you guys shared out your answers. Now this one's kind of a tricky one because depending on how you read the problem, I see 20 meters as the diameter. Okay, so I'm going to do mine a little different. I'm going to say that the radius is 10. If you read the radius as 20, there's nothing wrong with that. But I'm going to go a little bit more and say that it should have been 10. Okay? So my answer is pi 10 to the 2 power times h, which is 5. Pi 10 times 10 times 5, which is 500 pi, or, and these are meters squared, or 500 times 3.14, 1570. 1,570 meters squared. So either of those work. Okay? All right. So pause the video. You try. Go. All right. This time, R was obvious to be 4. So our volume is pi r squared h. Pi, the radius is 4 to the 2 power. The height is 6. So we have 4 times 4 times 6, which is 96 pi millimeters squared. Using the directions, 96 times 3.14, 301.44, 301.44 millimeters squared. All right. So, this was all about the volume of a can. All right? Now, we're not in a hurry. You're going to have a solo activity and your Mathia activity this week. So make sure you practice those. But let's keep going. All right. Now, we want to talk about the volume of a cone, an ice cream cone. Okay? With the point. An actual cone. Now, before we get started, I think it's cool to actually review and see where these formulas come from. So we have 3 different versions. Excuse me. We have 2 versions of this cone. And I'd like to pause and actually show you where this comes from and that this formula actually makes sense. Okay, so let's go watch a video.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
Okay, I always think it's kind of cool when we can actually watch a video to verify what we say. So we know the volume of a cylinder, pi r squared, h times, right? But when you turn it into a cone, when it goes down to a point, it's 1/3. 3 cones fits inside the cylinder. Okay, so now let's practice the same idea. Okay, using pi is 3.14. This one is to the 100th. That's 2 decimal points. Okay, whoopsie. That's 2 decimal points. Okay, so let's do the first one together. The volume is 1/3 pi r squared h. H is 5. R is 4. Okay, so 1/3 pi 4 to the 2 power times 5. Now this is how I do it. I do 4 times 4 times 5 divided by 3. Okay, let's go try it. 4 times 4 times 5 all divided by 3. Boom. 26, 2 decimal points. 26.67. Now, centimeters squared. So let's rewrite that. 26.67 pi square centimeters. We're going to multiply that times 3.14, 83.73, 83.73 centimeters squared. Cool. All right. Now, pause the video. You try the next one. All right. Welcome back. Okay. So now our volume, 1/3 pi r squared h. And in our case, we have 6 for the r, 3 for the height. It was upside down, right? So 1/3 pi 6 to the 2 power with a height of 3. When I write this out, I'm going to go pi 6 times 6 times 3 divided by 3. 6 times 6 times 3 divided by 3, 36 pi centimeters squared. Or 36 times 3.14, 113.04, 113.04 centimeters squared, or square centimeters. All right, pause the video. You try. Okay, welcome back. 1/3 pi r squared h. And in this case, we'll have 1/3 pi r is 15, so 15 to the 2 power. The height is 10. Okay. When I do that, I'm going to go pi 15 times 15 times 10, all divided by 3. 15 times 15 times 10, all divided by 3. 750 pi meters squared. Now, did you see that Monty messed this up? These were inches, inches squared, inches squared, inches squared. Okay, so 750 pi meters squared multiplied by 3.14, 2355 meters squared. All right, so today was all about volume, okay? Volume of objects, how much stuff fits inside, okay? So that finishes our Monday, Tuesday. We've got a solo activity. When we come back Wednesday, Thursday, we're going to do surface area. We're actually going to take a pair of scissors, we're going to cut this open, and we're going to discuss the surface area of our universal geometry tool, the toilet paper roll. Okay, and we'll do some of those problems along with grabbing our toilet paper roll off the wall and cutting it open and calculating the surface area. That's going to wrap up this module, because the last 3 weeks of school we want to go into something a little bit different called probability. So until then, see you on Wednesday, Thursday. Don't forget solo activity. Don't forget your mathia for the week. Talk to you soon.